right? So now see, if you consider the same example of cytosine, you can uh, call for that first video from YouTube. Okay, I will share in group also. You again you revisit the cytosine structure, एक मॉलिक्यूल को स्टडी करके आप बाकी बहुत सारे कंसेप्ट समझ सकते हो. कंसिडर देर इज नो स्प्लिटिंग एंड दे अपेयर एज ए सिंगलेट, बट हमको ऐसा नहीं मिलता है, वी डू नॉट गेट सच स्पेक्ट्रम. सो हाउएवर क्या मिलता है हमको, देखिए. सी, हमको ऐसा मिलता है, they each proton Ha couples with Hx and Hx couple with Ha as a doublet. But you see, ये 7.5 वैल्यू कहाँ आ रही है, ये बीच में आ रही है. You see? So this is the value of Ha, but it is split into two signals, and this value is 4 hertz. Remember, once you got the splitting pattern of this Ha, how we will get there? Just see the neighboring proton. एक है n+1 rule, two lines doublets. Measure the coupling constant. That is 4 hertz. Once you got the 4 hertz, now you check the whole spectrum left to right or right to left and find where is the J value 4 hertz. So here is J value 4 hertz. You can say these two protons, they are neighboring to each other. They are neighbor of each other. Okay, they are neighbor of each other. Fine. Yes, fine, you got it. See, ये है spectra, neighbor of each other. And if more number of protons are present, more number of protons, different types of protons present in the molecule, and they are giving doublet triplets. So by just having the by just having the idea of one proton's coupling constant value, and you can use that value and you can find out its neighbor. उसका neighbor आप मालूम कर सकते हो. Let us go for see this one. Just same. The 7.5 value was here, but it is split into doublets. So one lines goes beyond left side from the this point 7.5 same distance, and at downfield at upfield same distance. Okay, and this distance is called as 4 jx 4 hertz. So आप बताइए यहाँ से कितने हर्ट्ज आगे गया है ये. यस, कौन बताएगा. इस 7.5 से कितने हर्ट्ज आगे गया है लाइन स्प्लिटिंग लाइन.
2 hertz.
वेरी गुड, वेरी गुड. एंड आल्सो बैक कितना गया, 2 हर्ट्ज. तो यहाँ पर
2.
भी क्या होगा, यहाँ पर भी क्या होगा, ये आगे 2 हर्ट्ज से जाएगा, पीछे भी 2. दिस इज द मेक वेरी बेसिक आइडिया, वेरी बेसिक आइडिया ऑफ दिस स्प्लिटिंग, फाइंडिंग द कपलिंग कांस्टेंट वैल्यू. सो हमको अगर एक कपलिंग कांस्टेंट का वैल्यू मालूम होता है, एक कोई भी एक सिग्नल उठाने का स्पेक्ट्रम में से, अगर उसका वैल्यू मालूम हो गया कि 4 हर्ट्ज है, 7 हर्ट्ज है, 8 हर्ट्ज है, वो सेम वैल्यू का दूसरा कपलिंग कांस्टेंट का दूसरा सिग्नल देखना है और वो मैच हो गया तो दोनों समझ जाना वो नेबरिंग है. इस तरह आप बहुत सारे मॉलिक्यूल कनेक्ट कर सकते हो. ठीक है. अब ये स्पेक्ट्रम को लिखते कैसा है, ये तो हम जानते हैं, इट्स वेरी बेसिक. कैसे लिखते हैं, del 7.5 1h means it is for 1h, d for doublet, j is equal to 4 hertz. एंड ये एच ए नहीं लिखते हम, हमने बता दिया आपको. यहाँ जस्ट वी राइट 1h and another value del 5.8 1h doublet j is equal. तो ये मीनिंग जो है j values, whenever you find j value same, it means that this proton which has 5.8 and this, they are neighbor to each other, they are neighbor to each other. So this is what. Okay, fine, okay. Next point. Now see, consider this molecule and count the sets of peak. Yes, बोलिए. इसका नाम मैं बोलता हूँ IPC name. It is called as. Who will tell the IPC name? Yes, any one of you. Let us try. Try the basic criteria, basic chemistry. Who will tell the 1 minute? Sorry. Okay, fine. Yes. Can you hear? Can you see this? Yes. Yes. Fine. What is the name of this molecule? Anyone from you? It is called as, yes, dimethoxy 1,1-dimethoxy phenyl ethane. Its name is 1,1-dimethoxy phenyl ethane. How many sets are here? Who will tell? See, consider phenyl 5 protons as a one. वो एक जगह appear होगा. It will give only one signal. Okay, don't worry about it. All 5 protons of aromatic ring, they will give only one signal. I will explain you why. We had this idea, but still I will tell you. I will revise. We will revise it. So leave the ring. How many sets you will get from this part? Yes. कितने sets आएंगे? Yes.
Two.
Three sets.
Yes. Very good. Yes, Mr. Adil. One set for this 2-methoxy. One for
And
Yes,
this.
one
sir.
in CS2.
Very good. Very
One
good. Very
says
good.
two.
Very good. Very good. Now, our focus is this hydrogen. Okay. Can you tell? Can you judge where it will appear? Can you judge it where it will appear? That means chemical shifts बोलिए, coupling constant बाद में बोलेंगे. Means tentative value बोलिए ना, delta कहाँ पर आएगा? 2 methoxy are there, so it should be around 4, right? 4 point something, around
Yes,
4.
sir.
Now can you tell this proton? So see, I will show you. There are 4 sets. Okay, isn't it like this? Fine. So our focus is to understand about this Ha proton. Our idea, our aim is to understand about Ha proton. So Ha proton will couple with this 2 protons. Yes or no? Yes. By n plus 1 rule. और क्या देगा बोलिए? What it will give?
Triplet. Triplet.
Triplet. And what about this Hx protons? These two also will couple with this, and they will give
Uh, Doublet.
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 And you see here. You see here. The spectrum is before you. You see here, these ring protons are here at 7 point something. These 2 methoxy protons, they are 3 point like this. And here, this is what you are saying, this will split as a triplet and this two will as a doublet. You tell me, ये जो है ट्रिपलेट और ये जो हमने मैग्नीफाई किया है, यस, दिख रहा है सब लोगों को? यस.
Yes, sir.
ये जो डिस्टेंस है, ये डिस्टेंस ये दोनों के बीच का और ये दोनों के बीच का, इधर का या इधर का, नो प्रॉब्लम. विल इट बी सेम और नॉट?
Sir,
Same,
same.
sir.
Exactly
Neighboring
same.
Same,
photons.
sir.
Very
Same,
good,
sir.
very good. Yes, because they are neighboring protons. Because they are
Yes, sir.
neighboring protons. You are getting the point? Yes. So like this, we have a variety of examples, but basic point is to understand the mechanism. So now we have, see, sorry, we have here these two examples, 2 protons. If इधर भी अगर कोई example रहता, इधर भी कोई अगर रहता case, and there would be some other different types of protons, and they are giving triplet and doublet. So can we connect them? Yes. Once you got this, and we have this, and it will be given. Don't worry, it will be given in data. Definitely, it will be given. लेकिन for advanced example, it is not given. For unknown compound, अगर आपका unknown compound है, then it will be difficult for you. Now see, अगर आप ये इसको समझते हैं like this, suppose there is no coupling, Ha और 2H के बीच में कपलिंग नहीं है, समझो there is no coupling, ऐसा अंडरस्टैंड कीजिए, तो ऐसा इस NMR आएगा, बराबर है? Yes, isn't it? Yes. This is 4.6. So see, focus this Ha. Our aim is to focus Ha. बराबर है? ये आएगा नहीं, right? Yes or no? Yes. And this height will also tells you about number of protons. If number of protons are more, height of peak will be large. See, you see, this is the large peak. However, aromatic protons will not give the higher peak here. Sometimes it is a theoretical spectrum. In real sense, it also goes to very high. So this peak height also tells about the number of protons. So you see here this one. So consider, means ऐसा तो नहीं हो रहा है, लेकिन consider कीजिए there is no interaction between these two protons. Our focus is this Ha. So this will be this, but ऐसा नहीं होता है, ऐसा नहीं होता है. अब क्या करो, now consider ये जो Hx है ना, Hx का जो इफेक्ट है, ये अप्लाइड मैग्नेटिक फील्ड के साथ में है. You see what I'm saying you. Both the hydrogens, both the hydrogens, both the nucleus, both the Hx align with the field. Align with the field. Now we have done this. We have done this. Let us review the same sentence. This magnetic field sensed by this HA, that's why it appeared here, right? Yes. Barabar? Yes. Now, when you are added more nuclear field from these two nucleus, so it goes to this much higher value, isn't it? Yes. 4.6 was exact, but due to the addition of these two nuclear spin or nuclear field by these two hydrogens, it goes to the where? Higher value, right? Yes. Now consider third case. What? If one is opposing the field and one is aligned with this, out of these two nucleus, one is against this and one is in favor of this, so cancel करेगा वो एक दूसरे को, right? These two where they have contributed this much, when we have these two just opposite and these two cases are there. First case, this nucleus against another nucleus aligned. In second case, first nucleus aligned with another nucleus against with, right? Against, aligned against, right? So you see, so what will happen? That HA will appear at the same value. So two conditions are there. Condition one, when both are aligned, it goes to higher. When they are one is aligned, one is against. So two conditions are there. We can say two energy levels are there. So इसमें दो चांसेस है, इससे ये पीक से इसकी हाइट डबल होंगी अगर ऐसा केस, और ऐसा होता है, ऐसा आ रहा है. What is the third case? See, what is the third case? First case, both are aligned. Second case, one aligned, one against, one aligned, one against. What is third case? Both are against.
Both
So
are opposing.
you see, both are opposite. We can say same 4.6 जो expected value था, original value उससे कम हो जाएगा, right?
उससे कम हो जाएगा.
बराबर है. You see here, जितना बड़ा था when they were aligned, opposing से उतना ही कम हो जाएगा. और मिडल में क्या चांस है? ये दो चांस है, राइट?
मिडल पे सेम रहेगा.
हाँ, इसका मतलब हमको जो एनएमआर मिलेंगे इस तरह मिलेगा. यू सी, मीन्स ये एच ए ने क्या किया, ये एच एक्स के जो न्यूक्लियर स्पिन को सेंस किया है, वो कैसा किया है समझना है. वो तीन मेथड में किया है. कौन सा मेथड? ये जो 4.6 से वैल्यू बढ़ गई है, कब बढ़ी है वो? जब इसने सेंस किया है ये दोनों की स्पिन इसके, यस बोलिए, अप्लाइड के
अलाइन हो रही है,
अलाइन विद थी, यस. और ये कब फील किया है? ये लोअर
जब आप
वैल्यू.
दोनों अपोज हो गए.
और ये कब फील किया है?
जब वो मतलब एक अपोज
वेरी
कर
गुड,
रहा और एक अलाइन कर
वेरी
रहा.
गुड, वेरी गुड, वेरी गुड. ये था वो, ये था वो. सर ये केस था, राइट? नाउ सी, ये तो एच ए के साथ में हुआ इस तरह. सिमिलरली एच एक्स के साथ में वैसी होगा. ये दो एच एक्स इसकी कैसी फील करेंगे? व्हेन दे फील अलाइन तो थोड़ा बढ़ेगा. व्हेन दे दिस टू एच एक्स विल फील और सेंस दिस एच ए न्यूक्लियर स्पिन अपोजिट टू दिस, तो थोड़ा सा कम होगा. एंड दिस इज द रिजल्टेंट स्पेक्ट्रम ऑफ दिस मॉलिक्यूल. फाइन. ये देखिए, इस तरह हमने इसको समझा. स्टेप वाइज मैकेनिज्म कहते हैं, ये इस तरह था, फिर हमने इसको समझा है. ओके फाइन. तो दिस फॉर ऑल द पॉसिबिलिटी एंड अल्टीमेटली रिजल्टेंट हमको ऐसा मिलेगा. लेकिन कैसा मिल रहा है? वी हैव लर्न दिस इन द फॉर्म ऑफ सिग्नल्स स्प्लिटिंग ऑन द एनएमआर स्पेक्ट्रम. ओके फाइन. Fine. So this is another method. See, one more method is there by which we can understand the same concept. जब ये जो हमने अभी लाइन के सिस्टम में पढ़ा है, what we have learned here, we can learn from this point also. See how we can learn that this nucleus have only two energy level. One is opposing to this one, against this one, and one is aligned with them. However, these two nucleus have three chances. Both are aligned with, both are against with, aligned against, and third chance in which we can label them as a x1 and x2 protons. Because see, we cannot simultaneously, हम जज नहीं कर सकते कलेक्टिवली, हमको हर एक को इंडिपेंडेंट ट्रीट करना पड़ेगा. तो जब x1 को ट्रीट करोगे आप, x2 को दोनों को साथ में ट्रीट करोगे, तो दो चांसेस है. बोथ विल बी अगेंस्ट, अलाइंड अगेंस्ट, एंड सॉरी, बोथ विल बी अलाइंड विद एंड बोथ विल बी अगेंस्ट विद. सो हायर एनर्जी लेवल, लो एनर्जी लेवल. लेकिन ये जो बीच के केसेस है वो समझना है. पहले x1 लो, x1 अलाइन करो, x2 को अगेंस्ट करो न्यूक्लियर स्पिन को, ये फील्ड के. एंड सेकंड केस में x1 को अगेंस्ट करो अप्लाइड फील्ड के, एंड x2 को अलाइन करो, तो आपको और एक एनर्जी लेवल मिलता है. सो व्हाट विल हैपन? what will happen, this proton now, this proton, ये एक प्रोटॉन, ये इसको सेंस करेगा पहले, तो हायर वैल्यू जाएंगी, इसको सेंस करेगा, समझ में आया ना तुमको, ये प्रोटॉन ये दोनों को सेंस करेगा, तो ये वैल्यू आ गई इधर की लेफ्ट साइड। जब ये प्रोटॉन्स ये एज ए होल हो रहा है, नॉट वन, एज ए होल, ये इसको सेंस करेगा अगेंस्ट को, तो ये आ गया छोटा, सॉरी, इसको ये आ गया, ये स्मॉल वैल्यू एट द एक्सट्रीम राइट साइड। अब मिडल वन कब आएगा, जब ये दोनों को सेंस करेगा, दैट्स ऑल।
हम्म,
सो ये दूसरा मेथड हुआ प्रेजेंटेशन ऑफ स्प्लिटिंग स्ट्रिंग। और एक मेथड है इसको स्प्लिटिंग का, ये इसे कहते हैं ट्री डायग्राम बोलते हैं, ब्रांचिंग बोलते हैं। देखिए वो भी वेरी सिंपल है, नो चेंज, नो कोई भी नॉवेल्टी नहीं है, सेम थिंग्स देयर। सी, ये एच एक्स कैसा कपल होगा, ये एच एक्स की वैल्यू जो थी एग्जैक्ट थी, वो उससे कपल हुआ, और दोनों के बीच का डिफरेंस 5 हर्ट्ज हमने डिस्कस किया है, 5 हर्ट्ज आ रहा है, ठीक है, 5 हर्ट्ज लेते हैं, 5 हर्ट्ज, तो ये जे वैल्यू 5 हर्ट्ज है। तो याद रखो, ये जितनी भी लाइंस टूटेंगी और जितने भी सिग्नल्स अपेयर होंगे, ये देखिए ये, सो उनका डिस्टेंस कितना होगा, इसका डिस्टेंस 1 to 2
5
कितना है,
हर्ट्ज।
और 1 to 2 कितना है, 2 to 1 5 हर्ट्ज, और ये कितना है, 4 to 4 5 हर्ट्ज। सो यू गॉट इट, यस। सो लाइक दिस, and you know well, you are well versed about the Pascal triangle, in which we deal with the uh, different types of neighboring protons, and based on the neighboring protons we got the splitting pattern, doublet, singlet, triplet, like that. So see here, I have tried to give you the simple idea, कि number of protons you see, none, 1 2 3 4 like this, and splitting pattern, singlet, doublet, triplet, is very easy. And how to write the Pascal triangle theoretically, it is very easy. But remember, always remember, theoretical things never followed by the molecules. This is the theoretical thing, okay? Pascal triangle is a theoretical. No doubt, molecule will follow up to some level after the neighboring proton when increased by 4 and 5. That will not follow, and it gives you very complex spectrum. Okay, to resolve the complex spectrum, then we have a chiral resolving solvents. Many examples are there. Okay, fine. So this is what about the criteria of uh, coupling constant, finding and measuring the coupling constant, and connecting the neighboring protons just based on the coupling constant. याद रखिए, coupling constant ही बड़े बड़े रिसर्च लैब में ही होता है। When they are observing the NMR spectrum, they first find out the coupling constant value. जहाँ जहाँ मैच हो रही है, सेम आ रही है, वो सिग्नल्स को मिला देते हैं, और वो सिग्नल्स जो भी प्रोटॉन के रिस्पॉन्सिबल होते हैं, वो प्रोटॉन्स को कार्बन पे लेके वो मिला देते हैं। नाउ सी, व्हाट इज दिस, कैन यू टेल मी? वी विल स्टॉप, डोंट वरी, 5 मिनट्स में रुक जाएंगे हम, डोंट वरी। व्हाट इज दिस मॉलिक्यूल? ऑक्सीटेन बोलते हैं इसे, राइट? साइक्लिक ईथर है ये, साइक्लिक ईथर। सो हाउ मेनी सेट्स यू आर एक्सपेक्टिंग फ्रॉम दिस मॉलिक्यूल? यस यस, आदिल, कैन यू टेल मी? स्नेहल, ऐश्वर्या, बोलिए, how many sets you are expecting from this molecule?
two.
2 sets. But our intention is, see, it is this. Oh, मैंने पूछना था आपको, but I have shown you. See, no problem. See, there was a molecule structure for it. Actually appear नहीं हुआ है, structure था यहाँ पे. So you see here. Now you label this. कौन सा प्रोटॉन ये देगा ट्रिपलेट के, ये देगा ट्रिपलेट, ट्रिपलेट कौन देगा इसमें से? You see, there was a structure actually, but now it is not appearing anyhow. Can you tell it? No, okay, fine.
Near to the oxygen.
देखिए, ये जो सेट है, which is just near to oxygen. Resume the discussion. You see, this is the molecule, and this will give two signals, one for these two protons and one is for. So these two protons are same, they will couple with this proton, there are two protons here. So what is the splitting? Triplet, right? So
Triplet.
there is a triplet, and what about this? This will split with these protons. How many protons are there? You see, for this
Two.
proton, 4 protons. So n+1 rule. How many signals? 5 signals. You can
Five.
see there is a sorry. There are 5 signals. Okay, there are 5 signals. Okay, there are 5 signals. Okay, fine. Sorry. there are 5 signals. Okay, ये नहीं जा रहा है. Fine. Okay. Okay, right. Next point. So if you see this molecule, okay, if you see this molecule, again, last point, we will stop now. How many signals are there? Total signals?
Four.
4 signals. Very good. There are 4 signals. It's symmetrical, highly symmetrical molecule. Now see, we are not concerning about this. Okay, you consider this. What is this? Splitting bolo uski? Ethyl ki CH2 ki splitting boli. Yes, it will appear as a
Quartet.
quartet, and this will appear as a
Triplet. Doublet. Triplet.
triplet. And what about this?
Triplet, sir.
What about this?
Singlet. नहीं डबलेट आएगा डबलेट
Doublet,
Yeah.
doublet,
एक
sir.
ट्रिपलेट
Very good. Very good.
Doublet
Doublet.
आएगा sir नीचे.
Right. Right. Fine. And what about this?
डबलेट
Doublet. So
Doublet.
this doublet, this quartet, this triplet. Yes, yes, right. This is doublet, this is doublet. Because see, इसको ये neighboring में एक ही proton है ना?
Doublet.
Okay, right? Yes.
हाँ.
Yes. It's like this. Fine. You see, exact like you are what you are expecting, and we have the same structure. Fine. So can you tell me if molecule is not given and only spectrum is given? So you and this measuring is this is given.
अरे उसको कर देगा इसमें मॉलिक्यूलर एडमिशन कर देगा.
This is the distance. This is the distance. This is the distance. So this distance and this will be same. That we have shown the same color. And okay, this proton was highlighted there as with the color and here also. Can you tell this red color splitting for which proton? This proton or this proton? Chlorine proton near the chlorine or proton near the oxygen? Yes, who will tell? This red colored signal for which type of proton? This or this? No idea. So lower value, this is the higher value.
Near the chlorine.
Yes.
Near the chlorine.
Yes, that's right. That's right. Yes.
Electronegativity different.
Electronegativity of chlorine
Yes.
is more.
Very good. Very good. Electronegative chlorine is less than oxygen. So
Yes.
the proton which is in the proximity or in the vicinity of this oxygen will goes to the higher and as a doublet. So you tell if you measure this J value and this J value, will it be same or not? Yes.
Same.
Yes. it
Because
will
they
be
are
same.
neighboring.
Yes, because they are neighbor to each other. Fine. So here we have discussed this concept